Welcome you all to the video lecture of a computer architecture course. Here in this video lecture we are going to discuss about the topic related to the session 4, memory location and memory operation. In the previous video lecture we have discussed regarding to the evolution of the processor and functionality of a computers and the performance measurements of a processor. So now in this video lecture we are going to discuss about regarding to the location and operation of a memory. So from this memory location we are going to see how this memory location and the memory operation will be get adapted over in the computer architecture. So here this memory, the term will maximally places a major role in the computer system or else in a processing unit, since because it will what it stores both the data and an instruction for processing, which means that required for the processing. So normally this memory location is a what means as a fixed size storage unit, which means that will holds some data or a instruction, and with respect to every memory location it has the unique address. So from these terms we can able to get thing that what fixed size storage FSS, and this FSS stores what a data. So each data has what the address FSS data and address. This is the key terms is get involved over in this memory location, which means that a memory, whereas this processor uses these addresses in order to get access over the information whenever it needs or to write, which means that whenever it needs to read or write a data or an instruction. So automatically this memory address will access a basic number identification in order to get access over those information. So here this memory stores a data in terms of a bytes and words. Here this normally a byte is 1 byte is equal to what 8 bits. So a byte will consist of how many bits? 8 bits, whereas a word is a group of bytes. So a byte is equal to 8 bits, whereas this word is a group of bytes. So and its sizes will be dependable based upon to that of what means the processor's architectures, such as the values leads to 16, 32 bits and 64 bit. Here this efficiently this memory management will get be essentially makes us what the faster memory, which means like with the help of the register general purpose registers, program counter, instruction registers, so which are all small and expensive, while the slower memory such as hard drives as hard disks SSD provides a large storages with a lower cost. So the next thing we are going to see related to that of organization of a memory. So normally this organization, a computer memory consisting of what means a millions of storage cells, whereas these cells will can able to get stored over to a single binary value. Before in the video lecture related to the functionality of a computer, the processor will has the binary values only. So this binary value zeros and ones will represents the information. Those information will be get executed using the instruction over to the top of processor. So automatically we can able to get conclude that the word length defined to that what the number of bits is in one word. So the number of bits in one word will be says us to what a word length. Depending upon the processor's word length, the ranges between 16 bits to 64 bits. The organization of the processor will able to get transfer the information efficiently from where memory main memory to the CPU. So this is the organization of the memory tells us to that. So the next things is now we are going to deal with the word length and the word bytes. So here this word length and word bytes will related to the terms such as the 16 to 64 bits. Here we already see regarding to the of 16 to 64 bit in the previous which respect to this memory location. So here this 16 to 64 bit ranging things says to the of a word length. If now we are going to get consider a thing of a 32 bit computer, here this one word store the maximum value of a 32 bits. So 32 or 64 says the maximum range value of a bit storage to a word. So the 32 is the maximum range and 32 is 64 is the maximum range. Here these integers were being get classified with respect to ASCII characters A, S, ASCII characters. With respect to this CII characters, this bit registers values can be dependable. So this ASCII characters occupies the bits value of 8 bits. So this 8 bits from forms is what? 1 byte. So that is explained in the previous slide. So here this 32-bit word contains what? 4 bits. So 8 plus 8 plus 8 plus 8. So 8 bits gives what? 1 byte. So 1 plus 1 plus 1 plus is equal to what? 4 bytes. So with respect to these relations to terms of bits, bytes and the word, it is the thing which is important because it is directly influences what the performance of a processor, memory organization and the instruction executions is. So the next thing is the this is the term where the memory words has been get deviated with respect to this last word, ith word, first and second words. So the next thing is the address space, whereas these address spaces will help to store or retrieve what? An information. Here this each memory location must have what? A unique addresses. So this addresses will tells us the, which means that the total number of addresses that a processor can be accessed is known as the address space. So the address space depends upon to that of address lines is available in the processor. So like this address lines, the process with respect to the address lines is we can able to get the value of the address spaces. So if for an example a processor with 32 bit address bus can access of what? 2 to the power 16. Here the n says the bit values, so automatically 2 to the power 16 will gives the 16 million locations, which means the 2 to the power 16 gives us 65,535 memory values, which means my memory location. So the 16-bit address bus gives us an access of 65,535 65,536 memory location. Followingly, for 24 bits we can able to have the location, possible location of 16 million location. Followingly to the top 32 bits has of over of what? Around 4 billion locations we can able to get involved over to that. So the next thing is the byte addressability. So the byte addressability deals us with what? So the byte addressability will says us the computer system. Now modern computers are using this byte addressability memory. Here this every byte has its what? An unique address, which has been explained in the previous lectures also. Each byte has what? A unique address. That address will be get linked over to the memory. So whenever we are giving an instruction, the automatically the memory will gives us those things as to the top accessibility. So since here this byte always consists what? 8 bits, so assigning those addresses to bytes rather than to the top individual bits makes what? A memory management much more practical. That's for an example. Now I am going to get considered again, I am going to get considered to have a 32-bit length system. Each here this each word contains what? 4 bits. So automatically the consecutive words begin from the address such as here mentioned 0, 4, 8 and so on. This byte addressability provides us what? Flexibility, since because a processor can access either a bytes value or a complete word whenever it has been required. So the next thing we are going to see regarding to that of big indent and the little indent. So here this big indent leads us with respect to that of least significant bit and most significant bit. So this big indent leads us with to the top least significant bit, little indent leads to the top most significant bit. So big indent format leads us what? To that of a most significant bits has been stored in at lowest memory address. So the LSB and MSB will be get linked over to the top with respect to the memory address. So the big indent leads with here this big indent leads with MSB. So little indent leads is with the LSB. So what here the lowest memory address will be get accessed. So here the highest memory address will be been accessed. So that has been mentioned over here. This the lower byte address has been used with MSB. Little indent will have The lowest by address has been stored in where least significant bit LSB MSB. So this little endian and big endian will be related with terms of LSB and MSB. So the next thing is we are going to see regarding to that of the memory operation. Here the memory operation deals with the two things is read and write. So whenever we are going for a read operation, the processor senses the address, which means that it will pass the address of the required memory location to the top memory and request the stored data to get retrieved and to read those memory instruction and get execute. So this memory then automatically retrieves those instruction from that address and sends us a copy to what the copy of the data to the processor. So here the important thing we need to note that those original data are stored in a memory will remain unchanged during which operation? Read operation. Let's for an example reading simply how the copies of information without modifying the content of a memory. This is regarding to the of a read operation. So now the write operation, this write operation will tells us what here the processor will send both the memory address and data that needs to be must be stored. So this memory writes us the new data into the specified location. So specific memory location, which means that specified location, but in order to get replacing any previous content stored there, unlike the read operation which only copies the data, whereas here this write operation updates the memory by overwriting with respect to the existing values. So this operation will be frequently used whenever the program needs to save what the new results or updated variable during a execution, particular execution or a new executions. So these are the things that will have been covered over into the term of memory location and the memory operation.